This lesson is about potential energy, and by the end of the lesson you should be able to calculate the potential energy stored in a spring. You should also be able to calculate the potential energy stored due to gravity, and hopefully by the end you'll also be able to link the two equations together for exam style questions. So before you start, just a reminder of the spring constant equation, which you need to know for your GCSEs. If you're unsure, go back to the last video and watch that video first, but have a little go at the starter question. So hopefully you remembered that force equals the spring constant times extension, and in order to rearrange that to find the extension, you'd need to do the force divided by the spring constant, which should have given you an outcome of 0.1 meters. Now, whenever a spring is stretched, energy is going to be transferred. So if we look at this diagram and consider that I've now pulled the spring past where the weights have actually hung onto it. And if I do that, then what I've managed to do is store potential energy within the spring. If I was to let go of it, and hopefully the weights don't ping off, then what you should find is that the spring, that energy will be released and transferred to kinetic energy as the spring moves up. And have a think about the rest of the energy transfers that might take place should I do that. So as we go through it, from the very bottom we've got elastic energy potential, which is stored as I've pulled the spring down. And then, as I said before, as I let go, the energy is going to be transferred as the spring moves up into kinetic energy. Now once it gets to the very top, it will stop moving, and so all of that kinetic energy has now been stored into gravitational potential energy. And of course, again, as it starts to fall and move down again, the gravitational potential energy is transferred into kinetic energy as the spring moves down. And we get to the bottom again, where again we have this elastic stored energy, this potential energy from the spring. Now, if we were to disregard things like air resistance and friction, we could say that the energy was transferred directly. So whatever energy was stored in the spring would continue to be stored as gravitational potential energy at the top. However, in reality, this doesn't always happen because a lot of the energy will be gradually dissipated and the spring will come to a standstill. Now, in exam style questions, they will tell you to disregard air resistance and friction and to consider that the energy is 100% transferred. So whenever energy is transferred, we say that work is done. So when the energy is transferred, there's an equation that we can use to find out what the initial potential energy of the spring was. And what you need to do now is pause the video, write down the equation and have a little go at that question. So as you can see, the spring energy is just half of the spring constant times by the extension squared, and that gives us 0.25 joules. So the next equation you need to be aware of, and this is again one that you'll need to learn for your GCSE, is the gravitational potential energy. So anything that has height, anytime anything is held in the air, it will have gravitational potential energy, depending on the field strength of the planet that it's on. Here on Earth, we say it's 10 newtons per kilogram. So the equation that we need to use here is the potential energy due to gravity is the mass times gravity times the height of the object. So the higher objects are going to have much more gravitational potential energy than objects that are lower down. So again, pause the video here and have a little go and see if you can work out how much gravitational potential energy this pupil transfers into kinetic energy when they're jumping down off the chair. So hopefully you worked out you just need to do 60 times 1.5 times 10, which will give you a gravitational potential energy of 900 joules. Now, of course, again, in GCSEs, they would expect that to be converted if you disregard air resistance and friction. However, the rest of the energy in reality would dissipate into the atmosphere. So one of the things they do in GCSEs is get you to link these two equations and try to work out by using one equation to work out the potential energy, you then use that potential energy in the next equation in order to work out something like the mass or the height that that something has gained. So pause the video now, have a little go at these questions, and I'll come back and give you the answers. So these are the answers to the question. So again, you use the first equation to find out that the potential energy, or the energy that's been transferred, is 1.5 joules. The second question about how much gravitational potential energy would gain, again, what we've done is we are assuming that all of the energy has been 100% transferred, in which case we would go 1.5 joules. What we then do is use that energy into the next equation in order to get the height which has been gained. And in this case, it's 0.75 meters. Now, if you manage to get those correct and you're happy, then hopefully you would have learnt the outcomes of today's lesson. But please don't worry. If you're not happy with how that was done, go to the end of the video and I'm going to give a demonstration of an easy way of using these two equations together and linking them together. So for those of you that are happy, you should hopefully now be able to calculate potential energy stored in a spring, but also be able to calculate potential energy due to gravity. And you should be able to link those two equations together in exam style questions. For those of you that aren't so happy, please keep watching. Okay, so this is the question at the end of the video that some of you wanted me to go through. So we're just going to start from the first part of the question, which was about finding out the potential energy of the spring. So the first thing you need to do is draw the triangle down for the spring energy equation. And so remember, in our triangles we have a divide line and then the times at the bottom. And it doesn't matter that we've got three things to times. So the spring energy equation was energy in the spring is half the spring constant times extension squared. And what they gave us originally was 300 as the spring constant. The half doesn't change. And they gave us the extension as 0.1, so that's 0.1 squared. Put that into a calculator and that gives you the spring energy of 1.5 joules. And so that's how we get to the first question. Now the second question was about the gravitational potential energy and what that would be when it was transferred. So assuming that we don't have any air resistance or friction, that's going to be transferred directly. So the next thing we're going to do is put in the energy equation for gravity. And so here we have the same thing again. You can have 3 on the bottom. So we've got our energy, which is our gravitational energy. And then we have mass times the height times gravity. Now we've just said that if we assume that there is no friction and there's no air resistance, then this 1.5 will go directly into this equation, 1.5 joules. Now they also gave us some other information. They gave us the mass and they gave us 200 grams. Now remember, our units are really important, so we need to transfer this into kilograms by dividing by 1000, which gives us 0.2 kilograms. We need to times that by the height, and this is what they are asking us to find. We then need the gravity. We times this by gravity, which here on Earth is 10. So we now have everything we need to work out the height. So if we cover the height, we can rearrange the equation. So we cover the height, we get height equals the energy, gravitational potential energy, divided by, and here we need to remember to use our brackets, so divided by mass times gravity. And now we just plug in the numbers. So we've got 1.5 divided by the mass of 0.2 times 10, which is the gravity, which gives us 0.75 meters. And that's how you go about these dual questions where you need to use both equations in order to link the energy transfers. I hope that helps.